So let's start our discussion when it comes to vocabulary. So a graph is a data structure that consists of a set of vertices or nodes and a set of edges or relationships between those pairs of vertices. It maps relationships. Mathematically speaking, we've got something that looks like this, right? Suppose we have some graph G, and it's equal to the set of vertices and edges. Okay. They could be, vertices could be, and vertices, it could be completely empty, right, to represent that there's nothing here that we're mapping a relationship between. And if that's empty, then we don't have any edges because there's no relationships to be had if there's nothing there, right? But we could say, hey, there's an edge. We'd list out the vertices like A, B, C, D, right? Or let's go ahead and make this more explicit. We have something like Alice, Carol, Ben, right? And we have our set of edges, right? Alice and Ben, and that is one edge. And this would represent some kind of relationship between Alice and Ben, right? But Ben and Carol and Alice and Carol don't have a relationship because neither of those are in the set. Right, Alice and Ben have some kind of relationship, and it doesn't matter in this case whether Alice or Ben is first in this relationship, right? So a graph, and what is that relationship? Well, they could be friends on Facebook, they could be friends on real life. It really depends on the problem, and that's kind of the power of the abstraction of graphs. So we're going to limit our discussion to what we call simple graphs. These are graphs where basically there's only one relationship between two nodes. For instance, suppose we're discussing ways to get from one city to another, right? Pittsburgh and Philadelphia, for instance, right? We can travel from Philadelphia to Pittsburgh. We can go by airplane. We could go by car, right? Those are two different ways we could define that relationship. When we're talking about simple graphs, we only define a single relationship. So typically we represent these not in a mathematical format, but in a visual format for use. Typically, if you see a graph, you'll see it like this, which means that there's a relation with a line drawn between two nodes to represent whether or not there's a relationship, there's an edge, right? So A and B are two vertices or nodes. I come from a networking background, so the term node is used a heck of a lot more than vertice, but they're the same. They're the same thing pretty much. So I've got two nodes here, and they have a relationship between them. They have an edge. Same with A and D. A and E don't have an edge between them. Neither do A and C. Okay. And we typically just see this drawn, but it's just a visual representation of this these mathematical sets, right? Here's all the vertices, A, B, C, D, and E, and here's the edges. There's an edge from A to B, A to D, C to E, and D to E. Every edge is defined by the vertices, right? Every relationship is defined by like the people in it, right? So you can't have a relationship if there's no people in it, right? So same with the edges, right? If there's no nodes to connect, then there's no edge. So if there's an edge between two nodes like D and E over here, or A and D, then we say that there's a path between them. In fact, we can extend that further and say, well, there's a path from B to A and A to D, so there's a path that goes from B to D, right? We can go from B to A to D. And again, this is what we call an undirected graph, meaning that the order of these things in this relationship doesn't matter. When we get to directed graphs, which we will do very shortly, it will matter. As far as drawing these, though, notice that, again, we've been defining these as mathematical sets. So the physical layout of these vertices and where they are in our visual drawing doesn't matter, right? 0 could be here or it could be here. All that matters is that we accurately draw all the relationships, right? If we specify there's a relationship between 0 and 1 and 0 and 2, right, then we better have lines from 0 and 1 and 0 to 2, right? Both of these are correct ways to draw the graph, right? So keep that in mind. Now that's not to say that there aren't properties like that are associated with drawing. For instance, something that you'll learn later on, not in this class, is that there's graphs called planar graphs, and one of the defining qualities of planar graphs is that you cannot draw. Is that they can be drawn in a way such that their edges don't overlap, right? So non-planar, there's got to be a way for the edges to overlap, or there's going to be no way to draw it without an edge overlapping. So now getting on to directed and undirected graphs.